Yeah, welcome to this channel. In this episode, we'll be looking at how we can use calculus to determine velocity, to determine acceleration. Okay, if you have a position of an object moving in a straight line as this, then we can get the velocity. Velocity will be equal to what? Dx or what? Dt. That's the velocity as a function of time. That's what dx dt. That's that. Then we can also play with this to get the position of that object. How can we do that? Very simple. This will be equal to cross multiply. We're going to have this, and you can introduce integral to both sides. Okay, so that means position of an object as a function of t will be equal to what? Integral of this. So that's that on the position of an object moving in a straight line. Velocity as a function of t will be given to you, and then you integrate as such. Then the next thing to do now is to get acceleration. Acceleration is the v, the t. Okay, if you do your position as a function of t, if you differentiate it twice, so that will be equal to what? ddx ddt. That is how to get what? Your acceleration. Acceleration is derivative of ddt of velocity. So that's on acceleration. And we can also get v. We can do something like this. Okay, integrate both sides. Then you can get your v as what? As this equation as a function of t. So this is acceleration, which the equation will be given to you. Then you can get your what? Your velocity. So that's that on this question 1, the position of an object moving horizontally is given by this: x equal to t squared minus 40 on the interval 0 less or equal to t less or equal to 5. Find the velocity at time t. Okay, the velocity is what? You differentiate your position, okay, respect to t. So that will be velocity is equal to what? Dx dt. And that will be equal to, if you differentiate this one, that will be 2t minus 4. Okay, so that's your velocity. That's your velocity at time t. Then when the object is stationary, okay, that means your derivative, your v is equal to 0. When the object is stationary, it's not moving, velocity is equal to 0. Then equate it to what you have. Okay, and in that case now, 2t equal to what? 4, and t is equal to what? T is equal to 2 seconds. Then when the object moving to right and when it is moving to left, when it's moving to right, v will be greater than 0. That's the right. When it's moving to the left, v will less 0. That's the left. So let's solve those two equations. So we're going to have the velocity equation. That's 2t minus 4 greater than 0. And that will be equal to 2t greater than 4. So t is greater than 2 seconds. So in that case now, your interval will be between, that will be 2 less t less 5. That means t is greater than 2, or it's less what? It's less 5 when it's moving to the right. The second part, when it's moving to the left. So in that case now, we're going to have the velocity equation less 0. So we solve that. You're going to have 2t less 4. So t is less what? It's less 2. If t less 2, according to our interval, that means the value is between 0 and 1. So that means 0 less t less 2. So when it's moving to the left. Then finally, find the acceleration of the objects when velocity is what? Is 0. Acceleration will be equal to, just go to your velocity and differentiate that again. Okay, which will be v dt of your ds dt. Okay, so that will give you what? 2 meters per second. Okay, So, so that's that on this question.